So here we are going to see an example of pushing a 32-bit word onto the stack. So we have here two situations, the before and the after. Here we have our registers. Here we have our memory. And in the center here, we have the assembly code that we need to run to make this happen. So here's the scenario. There is a stack pointer, and this is the address that it's holding before running this code. And if you see, look at this address, is ending in C6, C0, which is here. So currently that means, so if the stack pointer is pointing to this location, that means that we already have an element here. So there is some data here, and that is basically the latest element that, or the element that is at the top of the stack. So that's, you could say, basically our last element that we have added. Not necessarily true, but you can think of it like that. So the stack pointer is pointing at this point. And before actually we look at more stuff here, I want to see the direction, because you should not always assume that like this is gonna be the higher address, right? So you have to kind of look at these addresses and see, I mean, they are in order, but it's not necessarily lower to higher, right? So we want to look at this number. So this is B8, and then we are getting BC. So that means this is larger than that. And then this one is also larger than that. So this is lower, and then this is higher, just looking at these numbers, right? So if I am adding a new item, which is this one, this is the item that I want to add. If I'm adding this new item, we said the stack pointer is going to get smaller. So if the stack pointer is pointing at this location, and we are doing 32 bits, so we have to move the stack pointer to the same size of the element that we are adding. So this is going to be 32 bits, and it's going to basically come here, and we have to update that stack pointer to move, or to be moved to this location. So because we are moving it, basically we are adding one element, and we have to point that stack pointer to this new element. So how do we do that? We basically use add-i. So as I said, the stack pointer is just a basic register. There is nothing special about it. You can do any arithmetic on it. So I can do add-i, stack pointer minus 4. So that means I'm reducing the stack pointer by 4, and this is in byte, so it's 32-bit. And then I'm using the save board to store the data from my register to the memory location that this stack pointer is pointing to. So we learned about this, the store word and load word in the previous chapter, but here is well, one of the really important use cases. So the store word, we said, take something from the register and store it into the memory. So how does it know where to store? This is the location that it's gonna store. So that means first you have to update your stack pointer, because if you did this after, you would have erased your old item. So the stack pointer is currently pointing here. First you have to put that in a new location, so it's gonna be here. And then you have your store word, so you're gonna copy this content into this empty slot. So straightforward. Move the stack pointer, and then update the content. So that's basically the one way of doing it. And I'm gonna show you a second way. But first, look at this diagram here. So this is basically after running this code. So you see that this content that we have registered 23 is now copied to this memory location. And you see that our stack pointer before was at C0, and then we did a -4 to that, so now it's at BC. And you can do that on paper, and you're gonna see that you're gonna get this number. Or basically we are moving it one up. Before it was pointing to here, now it's pointing to here. So that's kind of straightforward. Let's look at the other way of doing this. It's the same concept, it's just different in the code. So here we first move the stack pointer, and then we use the save board to take this content and copy to that location. So another way, alternative way to do that, we could have first do the save board, but with the offset of -4. If I did the save board just like that, I would have erased this old item. So instead, I can basically have this reset23 and the stack pointer, which is the old item here, but then I'm adding this -4 here that I'm gonna basically write to offset of -4 from the current stack pointer, which is gonna be here. So it's gonna basically be the same location, right? This is, it was here a stack pointer on its own. Here I have the offset of -4. And then after I do that, so at this point, this data is already there. After I do that, I am going to update my stack pointer location. And that's gonna be basically the same command that we have here. We are basically doing a -4 on it. So probably you are wondering which way is better, or why would we use one way versus another way. So it's not a big difference. Basically, it's the same concept, right? But there is one benefit to this second method that I would prefer this one actually. And the reason for that is, imagine a case that you're adding more than one item to your stack. So let's say you have, let's say 5 different variables, and they're all stored in your registers, and you want to take those 5 variables, or those 5, let's say, numbers, and you want to take that, all of them, and put them in your stack. So if you were doing it this way, you would have for each operation, or basically for each value to be copied to your stack, you would need 2 instructions for each of them, because once you are moving your stack pointer to a new location, and then you are doing a save board to write to that. So that's for the first variable, or the first register. Then you have to do the same thing again 2 times, so 2 operation. Again, move, and then store word, and then move the stack pointer, store word. So you have to do that basically 5 times, 2 operation, or 2 instructions. So that will be 10 instructions to do that. But if you are using it in this way, you're gonna have a more compact and less instructions. So it's gonna be faster. And the reason is that you can take this -4. So the first item that you're adding, here you have -4. So you're not moving your stack pointer. Your stack pointer is here. But then you are doing an offset of -4 for the first one. So you're gonna write here. For your second one, still you're not moving your stack pointer. You do it this time offset of -8. So it's gonna go there. And so on. Next time you're gonna do offset of basically -12, and then -16. So you can basically have 5 save board instructions, 1 for each register that you have with a different offset. So that's 5 instructions. And then at once, you just do this one. And basically, instead of doing -4 here, you do basically 5 times 4, or whatever that you moved. So you calculate that final location, and you just jump there. And that's gonna be basically 6 instruction versus 10 instruction. So it's almost 2 times faster, almost. And that is why I would prefer this way.